I elaborate. Yeah. The point is that I heard a little bit more about it. I mean, I never looked into Rust really, so. But in the meantime, I did hear a little bit more about it because someone said on Reddit something like blah 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 Rust in the kernel, and I was like, why? And then I got a few answers. So apparently they did this statistics on the number of bugs, and I think they is Google, and 70% of all bugs have to do with memory access errors. And based on that, they decided that one should use a language that prohibits that. And then there's a few languages possible, but then Rust is one of those, and that's the choice that was made. And now the hype is, because of this, between quotes, everyone is switching to Rust. So now my take on it is that I never run into memory access errors. I mean, my programs don't have bugs after I release them anyway. So, I don't know. Well, they do, maybe, but you know, I'm just not so worried about. The way I see it is that if companies hire incompetent coders, and as a result of that, there's a lot of bugs in their code. And then 70% of those bugs are caused by memory access problems. Then my take is just then they just have bad coders, which I already said even before I knew about Rust. Most professional coders can't code. So I mean, from the viewpoint of making a personal choice, if you want to learn Rust or C++, I would say there's no reason whatsoever to choose Rust, because you're scared of all kinds of mysterious bugs that you might introduce yourself. Just don't. You know, it's very possible to write code in C++ that does not have such bugs at all. But if you look at it from the standpoint of a career, and this push is going to continue, then you're going to work for a company who, by de facto, or this expression, hires bad coders, and then you might be a good coder, but your coworkers are still going to be bad coders. And the management are bad coders, or they can't code at all, and they make decisions not based on their experience in C++. They make decisions based on policies that are, you know, almost politics at some point. So then it seems not totally unlikely that you need to know Rust. So if you're at the beginning of your career, you're still young, and you must make a decision, then maybe Rust is the better option to learn at this point. You know, just, you know, as a career decision, say. But I stand with my remark that, you know, the background of it, of the whole thing, is that there's just such a shitload of really bad C++ coders in the world. We introduced those errors to begin with. Now, my gut tells me that having a language that prohibits you from making certain errors is either inflexible or slower or both. But I might be wrong. I also understood that Rust is doing most, if not all, of those checks during compile time. But yeah, it's in language, so there must be restrictions. I can't say anything sensible about it until I would have learned Rust and started coding in it as well, but I'm not going to do that. The only thing I can tell you for certain is that when I saw the reasons for why people think that C++ needs to be replaced with something like Rust, I was like, what? What bugs? You know, that is not the problem of coding. The problem of coding is coming up with a good algorithm and make that algorithm work. People still wrestling with bugs and crashes due to wrong memory access and stuff. I mean, they have a long way to go. I don't think this is the problem of coding at all. The only thing I'm struggling with here is my algorithm. And the fact that I'm getting older. Program is too complex to have in my head all at the same time. I used to be able to, I think, have more in my head at the same time, and then I could write more complex programs. Tractor, no, never heard of it. If you don't mind, I want to concentrate on this, otherwise, you know, I forget. What was I doing here? Scratch area. If it is less than the best tolerance, then we have an improvement. If the last improvement was... Yeah, is it larger than or larger or equal then? I want to have 3 failures. So there is no increase. Let's say this failed. So there is no improvement. There has been no improvement. Otherwise, it would have been equal. So 0 means, well, greater or equal is 0 means that this was an improvement. Then I guess that this means there has been one time no improvement, and that is this call here. And I want to have 3 of them, so that should be that then. Then it's greater or equal. Let's just print And if that happens, I want to set done to true. So we simply use the result that we have, but not immediately. I want that to happen only if the tolerance equals the best tolerance. So I'm going to return here. But I need to notify that that we returned here and not at the bottom. So okay, maybe by default I return true, which means that this must be a boolean. I don't really care what the result is here, because, well, actually it must be true always. We're going to add it and then it must be true, right? It's kind of like we should definitely do this if depth equals 0, or God, why is this so complex? Too many things seem complex these days, I have to admit. Okay, so assuming that this never happens and we always return true. And if we reach a tolerance, then we just do this, which like we did before. I return true. We did not reach tolerance, then we increase the depth and split the function in two. I call solve recursively both parts. After which results should have been filled already. So we can also just exit this. I mean, without changing done, return true. Yeah, I think this works as long as we never return false. Because if we don't return false, then we will just keep calling solve recursively until at one point done equals true, and then we don't call solve, and we do this, and we return true. And that means that we return at all. So we return from this function and we return from this function while done is false. So then we return true again. And that means that we just unwind the stack and return all the way. But now this is the special problem here that if solve return false, then I have to do something special. So I'm going to test that. to left and right, or 0 and 1. Suppose this one returned false. What does that mean? That means that it did not do this. So someone who did this must have still x res ID equal to equal to this value. Because either this line or this line has been called at some point, which means that either the best x tolerance or the best y tolerance is equal to one of these values. In one of the callers. And if we reach that caller, then we want to do this anyway. And then we have done it, so then we can return true. Now, if that is not this caller, then we don't want to do this. And we still have to return false. So maybe I should just do the return here. Does this make sense? That is a good question, isn't it? Okay, so if we ever come here, then that does not make any sense, unless done equals true. So if this is false, so done is true, then we come here, and it's true anyway. Let's just assume that done is true here. And then, like I said, as long as solve keeps returning true, then both are true, and then we just return true here as well. Because this was already done. Those trues come from this true, which means that both of them already did and plays back. But if false is being returned, then that is because of that. In that case, we have to detect if this caller something like if the x res ID of this caller equals that, then this is the caller that did call this. No, I don't care. Sorry. Let's just compare these two. Yeah, but only one of them is false. So if this is false or that is false, now we need to do something special. So I might as well return true here, actually. And then do something here, and then return false here. I don't know how to call it. Curse of calls. So both are successful, and this one is successful as well. One of them fails, and we get at the point where the last improvement is equal to the current depth. Then that's the values that we want to use. No, the only thing that is being used is I mean, we can just continue. We can just do this. So in this case, if this happens, then I want to continue with there. Like that, I guess. Seems correct. So say this one returns false, success is false, we don't do this. And then if this is true, then we return false again, which means that we return here or here, and therefore decrement scratch area depth, which then might cause this thing to become false. Because this is now less, so it's not larger anymore, it becomes equal. And then as soon as it is equal, then this is also not done and we fall through. And then I want my debug output here to be printed. Yeah, on the fall through maybe. Shriman Vikram. I can. But it's so complicated, it takes half an hour to explain, and I have such a bad experience with explaining things with relation to view account. So my first question is, are you still there? Sol should return a value. You're still there, okay. I'll show you in a second, as soon as it compiles. What should I return here? If the curve is entirely outside, don't bother rendering. I guess I should just return true then. Yeah, same thing, I guess. Very fuzzy, I guess. No idea what we're doing. Well, it compiles, so... Well, in order to explain this to you, I'm afraid I have to first zoom out a little bit then. And now we had fun, and that one, yep. Example function. So we have a function here with minima and maxima, and this is a pretty random generated function. Just added a lot of sines and cosines together, and it's a Fourier name. And we start here, and we want to find the global minimum, which is this one, of course. Unfortunately, it will not find that one, because the algorithm is going to search for a local minimum that has two worse local minima left and right of it. And this one is lower. So it's going to find this one first and then reject that one because it's higher than this one. But it likes that one better and that one even better. And then we crash here. The function is discontinuous here, which gives me a problem that I'm trying to find a workaround for. Anyway, the way it works is, well, we begin with the gradient descent. So this is the gradient. Oh, what the hell? This is the slope in the starting point, random starting point, 5.5. So we make a step down because you want to find the minimum. And that we went so far that we came in 1. Okay, but now, and then I fit a cubic between 0 and 1. And that cubic has a minimum in between these 2 points. So the minimum must be between these two, hence the red arrows. The cubic is, as you can see, because it is being drawn here, if you can see that, it's a really, really good fit for the function. So we're going to jump to the minimum of the cubic, but that is almost already at the right spot. That's 0.2. Then it fits a cubic between 2 and 1, which now has a minimum like there. And now we have 2 points so close to the actual minimum that the next cubic is going to give us something that is detected as the minimum, well, the good enough minimum. Then a 4th degree polynomial is being fitted using the 3 closest points, probably 0, 2, and 3. Sorry, there's a 4 here even. I think there's 2, 3, and 4 here. Okay, so 4th degree polynomial is fitted, and that is again pretty damn good. This fit here that says, well, the neighborhood here is a maximum. The prediction for the minimum is bad because it's low, but in terms of the x-coordinate or the double coordinate, it's reasonable. We're going to the right here because this is lower than that one. And that is correct because this one is lower than that one. For some reason it turns out to work every time. So we jump here. And now we jump there and then we jump there and we found this maximum. Again, as soon as we found a local extreme here, in this case a maximum, plot the 4th degree polynomial, which is this teal line, which now has the lower one here. Well, of course, we're not going backwards because we came from here. We're just going in the same direction. So we jump to this minimum instead. And then we fit a cubic again from between 6 and 8, which has a minimum here. We jump there, and then we do it again and again, and we found this minimum. Because this minimum is lower than that minimum, it continues. Otherwise, it would give up, go here, and then explore the other side. So we go here, there, find this one, continue, jump there, find this one. This is again lower than that one, so we still continue. Now we're going to find the maximum. It does find the maximum, even though it's discontinuous here. It found it, and now something goes wrong. Namely, note that 19 and the 8, well, if the numbers are written above it, it's because that is the detected maximum here. Or if it is below it, sorry, it's above it, it's a local extreme. So either the maximum or the minimum. But as you can see, the 13 here is that the point 13 is here, and yet there is a 13 written here. The reason is that there is a cubic between 13 and 14, and that cubic was used to find this maximum. So if you fit a cubic through point 13 and 14, then that cubic has a maximum in this place here. And I call my cubics by the name of the node on the left. So the cubic between 13 and 14 is called 13. This local maximum was found by that cubic, and therefore we put the 13 above it. It refers to the cubic. In this case, 18 and 19 are somewhere here. You can't even see it. And 18 is the one on the left, so the cubic is called 18, therefore the 18 is here. Same thing as here, but then written all on top of each other. Now what happens? We're going to jump to here because we still go to the right. But yeah, the function here is 0. So what happens is we do a backtracking, just go back, and back, and back, and back, and back, and back, and at some point something goes wrong because there it goes wrong. And in the meantime, we couldn't see at all anymore what was happening. So I had a zoom in. We're going to zoom in like ridiculously. This is the discontinuous thing. And here you see a swing now. Oh my God. That is, of course, not true, not accurate, but it's the best I can do apparently. Because what I just did was make a change to the code that chops a function that has to be drawn into Bezier curves. Apparently at some point we just couldn't improve on the accuracy of that, and then we gave up, and then we just draw what we had, and then you get this swing. It's kind of the same thing you would see on an oscilloscope, I guess. If you have a certain bandwidth, then it drops here sharp. Boing. Okay, anyway. There are point 18 is off the window, point 19 is here, and this is where the maximum is detected. which has then 18 written above it, because that the cubic between 18 and 19 is being used to detect this maximum. And then we get a point, on the right here of the window, which then gets closer and 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 closer. Now it's visible. This point here, that looks like an 8, I guess 28, yeah. 0.28. Yeah, we have to find a cubic that mimics the function. So basically the function is being cut into little pieces that are all fittable piecewise exist of cubics. So we need a really sharp full drop off here with the cubic. So it's going to and it's drawing nothing again. Damn it. Before at least I had something. I think it's still printing it. You have an infinite flood of failed to reach requested tolerance. In fact, I have so many that it looks like it's really? I can't move my window. Okay, so my mouse is not working. I think that thing is on top. Can't even switch the windows. Keyboard is not working. Keyboard's not working. Mouse is not working. Can move the mouse, but it can't click. Normally I have at least a keyboard, but you don't have that either. Where's my phone? I know I need to log in with my phone to kill this thing. Okay, I think I'm going to stop again. Just getting tired of this. The wonder of a phone. Yeah. Yeah, okay, man. I mean, I have lots of other tests. Oh, that's bad. My keyboard is still not working. Shit. Oh, at least I have this. Wait a minute. No, my keyboard is dead. Okay, that's problematic. Damn it, how do I recover from that? So I can log in remotely. Oh, I'm still logged in even. PS AUX piped into grep Fourier. Shit, no, it's not running. There is no Fourier test. No, I guess I have to reboot then. Wait. Launch a new console. Oh, here I have it. That's the problem with the console, maybe. Oh, it recovered. Okay. No. I'm going to play a game of chess. Haha. Good morning, Carlo. No. I lost so many games today that my rating has been dropped below 1900 again. Let's bring it higher. 1881. Seriously. Okay, we want to have pawns in the center. Let's develop all the pieces. I take, he takes. I don't know. Why would I not take? It's a pawn. Can't give check. It's probably I'm falling for an opening trap now, but I don't see it. Okay. I wish I had castles by now, but that might be annoying. What if I just do this? And then I get that one, and then I do this, and then he takes it. I can also do this, and he does that anyway, because I can't take it. Do this. At least now I can still push it. I take, he takes. Not that much difference. And I can take the knight with the tempo. Kind of. Maybe it helps me. Let's do that. I'm one pawn up. So now we can castle. I can castle. I'm sure I can castle. Let's just castle. Yes. Okay, now if we do this one away, I can move my knight again, which is not a bad thing. Oh, yeah, that is a bad thing. Damn. I don't like that at all. We have to develop this still. He's going to push this pawn, I'm sure of it. And then attack here, perhaps. That was a good move, man. Okay, I can go here, but then the pawn comes. Very scary. Yeah, and then now go here. He just castles. Sacrifice my knight here, and then give check. At least he can't castle then. But that would be 2 points. Yeah. No, actually it's not, because I can take here. Try that. Let's try it. Oh, we can go here. The attack on my knight and threatening mate. So then I can only narrowly escape from losing my knight with attack on the queen by giving a check here. And then the king attacks my knight, and then Then I still have to move my... well, maybe I can push this pawn on? No, not really. I'll just have to put my knight here then, attacking the bishop. He's not doing that. Wow. Okay, I'm gonna take this one. +2. I should do something about this horrible, horrible bishop. Okay, if the queen attacks this point, I just go there. That's no problem. 1, 2, 3. Oh, I'm giving a pawn away. Oh, why? That's pretty stupid. Okay, now I'm not giving a pawn away. No, I think I'm winning it. Even though my bishop is still really not developed. I'm winning this pawn as well now. Oh, well, okay, I'm not. But yeah, eventually I'm going to win this back, of course. Oh, that's not bad. That is not bad at all. He's going to go here. Attacking that pawn? Wow. This pretty much sucks. I go here. Take the rook, take back, take again, take again. Bishop here, take, push. Now the pawn threatens to promote, and my king is here. Dang. So I probably have to take first. I think that would work. Now we run to the center. think it's going to push this pawn. Kind of sucks. Maybe we should do this. Then I can just take it like that. I should have gone here. I thought my knight wanted to go here, but of course the knight wants to go there to attack that thing. Anyway, now I'm close enough to be able to exchange this rook. So now the bishop comes here, I can just go back. Take, push, and I can stop the pawn. Fuck this. If I go here and he pushes the pawn, then I lose my knight. That looks good. King is outside of the square. He's like very far away. So the knight goes here. I pick up this one. My knight is so far away from everything. Shit. Again, infinitely far away from everything. Yeah, it's unbelievable. Didn't get any rating points. Where the hell did I give that away? Here, I gave it here away. What did I do? King move. And the knight wins. Why? Because nobody knows. Oh yeah, it wins one tempo with going here. Checking this. I mean, he has to go there. He really has to go. I'm threatening to do this. He can't even take it. Okay, I'm gonna go with this move because then I can't do that, but I can still do this. Still has to do that, and then you lose that one. You gotta be kidding me. This is totally winning. What if we go there immediately? Then I go this way. And now we pick up this one. And this pawn is not dangerous, of course. It's not, totally not dangerous. This is also a nice attack. Yeah, attack this one, I can't even push it. Horrible. Okay, he's gonna go for that pawn. And we're not even in a hurry now. -4, and if I take here, it's a draw again. Way too difficult. Why did my king have to go that way? Yeah, if you take this, I take that one. Otherwise, we sneak in like that. Whoa. Yeah, unbelievable. I did a good move. Yeah. E5 was the best move. This is 1.1, 1.2. And this move is 0.2. No, then this one's better. Mm-hmm. Taking here is not good. Because the bishop goes there. I don't think he did that. Probably still should do this then, yeah. But then he wins a pawn and he just does this, no? No, this is good for me. Oh, what the hell. Now this is a threat, or that. Yeah, this is mate and attacks a rook. Wow. But this is now also possible. Trying to take this one, trying to take that one. Gives an intermediate check, which I block apparently. Then it just takes my rook. I can still pick up that one. Exchange castle. Yeah. That was not a good move. How can that not be a good move? He's trying to take my pawn. So confused. What? The best move is resign or something? What is this? Why is that not a good move, man? I mean, this is a good move, but that's also not it. So I just should not defend the pawn. Really. Why? Okay, so he's just going to take it, and then what I do? Oh, the pawn then can no longer be defended or moved. I just give away this one for free, and then we get that one back. Still lost the pawn. Nobody gets this. So this ends in plus 0.3. And this? Plus for what the fuck? Oh! Okay, yeah, that's definitely not a good move. But then what I did, this also. I'm so shocked. He should have taken it. He did take it actually. Took it back, and now it's plus 5.3. Wow. Nobody understands why though. I did a computer move, and then I did not give up. I went double question mark. Ooh. That was also a double question mark. No, I'm winning. I'm winning because the knight comes in the game. But no, I did not do that. This pawn is stopping the knight. Of course I should have attacked this pawn twice. Of course. This is so easy if you see it like this. I have no clue. But it was wrong because then the knight comes here, attacking that one, stopping my king from going forward, losing a pawn. Or not. Now going forward is nothing either then, or then I can at least do this. Try that. That was good. He does this, and then I can push this pawn, yeah. No, white is still 100% winning. Okay, white was winning anyway. So plus 6. And if I go here, it becomes... It's better. It's a double question mark my ass. It went from more than plus 6 to plus 6.0. Plus 6.3. Come on, double question mark. Nothing, no double question marks. See, now it's a computer move. It's the best move, man. It is the best move. It's not a double question mark. Yeah, blunder. King f6 was best. Throw 32 cores to edit. No, all threads. That's the right move. It's not a blunder. It's the best move. Still the best move. It's plus 7. Whatever. Right, okay, good night. Stopping again. Second time I stopped streaming today.